Okay, yeah, I'm going to start by saying how honored we both are to be here. It's an amazing conference, and I think we have an amazing talk, but I can't speak for ourselves. I can say that we put in a lot of effort, and we're excited to be here. So I guess now is a great time to start. What do you say, Elad?
Yes.
Let's do it. Okay. So I would like to start by presenting Josh. Josh is the world's best racing driver. You better believe it. And now I would like you to imagine this. Imagine that you're with Josh in this car. Next. I'm just going to use this. Right. Is it? No, okay. Now you can imagine that. Now imagine that you're sitting in this car with Josh. You're together in a racing team. He's on the wheel. You're right there next to him. And you know that he's the best driver. So you know he can get it done. He can hit it on point. He can get this machine to work at its best. But here's another question for you. Having that in mind, would you let Josh plan and build the engine of the car? I mean, he really is a very good driver. But does it mean that he should sit in the workshop and plan things like, I don't know, the fueling system? I don't know. What do you think about that, Elad?
So I think, and sorry, a bit my throat, I think this approach that we see in racing, when we have a racing engineers helping the driver to succeed in the job, why do we not doing the same thing as we discussed about data? Most of the time when we speak about data, data is isolated. It's not just part of our development teams. Sometimes it's can be a BI engineer, sometimes could be my backend engineer, or sometimes could be data pipeline engineers. But in most of the cases, we as the DevOps are not part of this infrastructure. And doing this without a DevOps, we raise the same questions of observability, security, performance, and for example, high availability. So why in other places where we understand there is difference between roles, when I am the driver, I'm responsible to be the first to win the race, but also I have all my technicians and engineers help me facilitate it. Why not advocating the same thing when discussing about data? And this is what we're trying to do in a talk. Often, there is a separation between data and DevOps teams. Each work is done in isolations. Most of the time, DevOps teams are struggling to work with their application teams, running microservices again and again, CI/CD, and all the SDLC practices that's already done today. But we would like to start thinking about how we can bridge the gap between common cloud native stack we're using today and also our data efforts. And again, we are not talking about big companies that have a dedicated data ops teams, and this is part of the main job. But for most of us, this is a sidekick. This is something that we don't have a dedicated person to do so, because DBA today is their position. It's not happening in most companies. My name is Elad. I'm a tech lead at Terasky. Terasky is a consulting company. Our focus is mostly on cloud-native applications. Most of the time, I'm working on public cloud and cloud-native solutions, and I'm technology advocates, been in sessions in KCD and in other communities around the world. And again, what I'm trying to amplify here is that we see the difference. We see something changing, and we would like to discuss it with you. And me.
All right, I guess now it's time to say my name. My name is Mey Beisaron. I've been a backend engineer for over 5 years, and then I decided to move to the dark side, and today I am a senior DevOps engineer at Forder. Those are the languages that I've written code in, but my favorite one until today is Clojure. Don't say a word about it, I don't care. And so, one other thing about me I'm an international public speaker. I talk at many different tech conferences because it is important for me to share my knowledge. And then I also help other people become the tech speakers that they want to be. So talk to me if you want to go up on stage. And last thing, I don't think you missed the fact that I kind of like Star Wars, just to have a thing for buying merch. That's about it. And now, let's get back to business. As Elad said, we're here today to show you how and why having DevOps engineers being part of the plan and deployment of databases is not only beneficial, it's essential. And we're going to do this by diving into three common problems, and we're going to present 3 solutions. Now look, there are other ways to solve the problems that we're going to present here today, but the solutions that we're presenting are all actionable, they are all open source based, and they all lay a great foundation for bridging that gap between DevOps and data. And so, let's start with the first one. Provision, set, go. Running databases on Kubernetes with Cloud Native PG. Do you see how we kept the racing theme over here? I love it. Anyway, let's dive deep into this. All right, so you need a good database reliability, right? I mean, don't we all? And then, let me guess. Despite running everything on Kubernetes, you went with a managed database, right? And that's okay, because then when you started with one database instance and you realized that maybe you need to assess your data workloads, you noticed that there might be a difference in the read and write ratio, so you were like, okay, maybe we need more than one database instance. All right, let's do that. And then you started looking even further, and you realized that you might even be able to save some cost if you have more than one type of instance. And so you added a few more instances with different types. And then comes the high availability. Okay, we all need that. As the company grows, we have more data workloads. And so we decided to have a few availability zones. All good. We can do that with a managed database. Right, Elad? What do you think? I mean, no other option, is there? What do you think?
So I think it's tricky because what I'm going to show here is the creator is here. So plus to you, you're doing amazing work.
Not stressful
It's stressful for me, not for him. Let me see how many comments I'll get after. But please don't kill me. But again, you've done an amazing job. So I would like to present Cloud Native PG. So it's an open source and vendor lock solution. It was contributed by EDB in 2022 into the community, and it's open source and it's amazing. You see a lot of features. PR are moving in amazingly, and this is community that are getting bigger and bigger. But why we need it? We need it because if we think about an operator, we want it to be declarative and we want it to be an immutable design. But immutable design, when you think about database, it's a bit risky. Why? Because the database has a state, it's a database storage itself. So how are you going to handle it? Are you going to handle it with solutions like stateful sets? Are you going to manage it by running the Patroni to manage election if node fails and recovery? This is all state and configuration, so this is much more complex. But Cloud Native PG in the operator doing this logic. So in this case, for example, if you want to do resize of your data store, by directly communicating with the PVC and the storage class, you're able to change, for example, the data storage type and resize it without running a very complex data migration, which is very important. And this was, for many years, one of the main challenges, because when we spoke about Kubernetes, it was almost and always was stateless application without any states. My pod destroyed, I rerun it again, and my storage is, guess what, in the RDS. But this is not the case. And of course, it's come with a high availability with an automated failover, which is one of the features that's making him a production ready, not just as managed service, as we saw before. This is a very basic architecture. And again, this session is less for data engineers. It's also for us as DevOps engineers. I don't want to hassle you too much on the data. So by the end of the day, you're going to tell me, OK, you want me to be a DBA. No, this is not the case. And we're just going to take 2-3 points to discuss about the challenges that we as DevOps engineers taken into account, which is going to really be beneficial. So we have a simple Kubernetes cluster. We just installed the operator. We see that you have application. Our application has 2 services exposed. One of them is the read-write, which is the main one service. Another one is the read-only service that can be sometime as a failover. And sometimes it could be also connected to applications if you need some kind of read-based operations. And of course, you see the mechanisms that do the replication. We have the primary one. And upon every change, it's also updating the secondary instance. But again, how it's doing so? Let's take a look on the right end of the architecture. You see the storage. You see that we run in backup. For example, here we're using a cloud-native backup solution. But I see there is something here that's called WAL file. It seems something that is not relevant for me as a DevOps. Maybe it's some super technical stuff about data. But let's discuss about how do I get it. And this is why it's so nice. Basically, what you see here, you see a CLD called cluster. And I'm defining 3 elements in the spec. The number of instances that I want to spin, the minimum secure application, and the maximum secure application. So it's me now that I have a topology with run, 1 write and read instance. 1 read instance that in a fraction of a second will be updated on any transaction made on the main database. And another one that eventually async-based will be updated. But again, it will be, for example, for performance, if you want just to split some of your read and reads to a different instance. But again, you see a high availability topology. But when you're speaking about Kubernetes and high availability, there is more to it. For example, if you want high availability, you want to make sure that it's going to run in a different availability zones. You also want to make sure that it's running on availability zone in one instance, and there is no other workloads running on the same instance. This is the definition of doing a high availability solution. But again, this is why it's so nice. Take a look here. Node affinity, I'm just defining node selector terms, selecting the specific availability zones that I would like to set up this workload. Then all I'm doing is saying that I want to run 1 instance only, and also with the taints, I'm making sure that there is no other workload running it, because no other workload will have this selector. So by doing so, I'm just leveraging the same knowledge that I have as a Kubernetes administrator. This is why it's so important. The second one is what's going to happen in a failure. This is exactly what you said. By cloud-native PG operator, listen and understand what's happened. If it's disk failure, if the pod restarted, or some storage issue, it will be automatically understand it. And by us just connecting into the read-write service, behind the scenes, the operator will change into the next instance. And what's going to happen here is that now our secondary instance was elected to be the right instance, the master one. And it's going to write seamlessly. But again, this is very nice. But you also discussed about the storage. What is the WAL storage? And again, why it's relevant for us as a DevOps engineer. So the basic mechanism of write-ahead log is the following one. And let's try to very simplify it. So I have a service. I'm writing the transaction into my database. And what's happened behind the scene, I'm automatically taking the transaction log and put it in a data store. The data store is very fast. It's not inside a database. It's inside a file system. And now we have a persistency that if something happened, the first operation happened was to store it in a disk. And later on, I can use it to recover the data. Upon completion, and even before updating the other services with synchronic replication or asynchronous replications, I'm returning the commit, and then the transaction is ended. And again, by doing it very fast because we're writing in the disk, we also get improvement of our transactions. And of course, later on, as we saw in high availability solution, if we have more instances, the data from the log is replicated to the other instances. So the log file, if you just take a look at this example where you just run SSH in command, it's just a directory. And why it's relevant for us? It's relevant for us because if we want to boost data reliability and transaction efficiency, it's not up to the DBA or the data engineer or the backend engineer to understand that now he needs to select a different storage type. But take a look here. It's so easy. The cluster CRD just have a wall storage section where you define the size, and you just pinpoint into the storage class, as you see here. And again, storage class is the same thing as always. And if you want something which is much more faster, all you need to do is, for example, taking a provisioner for AWS EBS, if you're running on AWS, and select IO2 if you want a very performance writing operation. And this could boost your application. So again, this is a second example how us as a DevOps can give you the benefits of things that you're missing by understanding how you set up a highly available replication in high availability scenario, and also how you can boost your application both on the transaction performance, but also a way that you will not miss any transaction in a high available solution. So the next issue, and this is one we see in a lot of customers. We need a reliable database. But again, when we speak about it, we see a lot of customers doing the same thing. The developers are responsible for the schema changes. They're just writing for them this XML set that define a change set. But they're running it as part of the application code. And this is a real problem, because we're coupling our application code with our database schema. It sounds harmless, but at first time that it's run and schema changes happen and destroy our databases, what I'm going to do, how I'm going to do rollback. This is very, very late. We would like to shift left, or at least separate between them. And schema changes not always quick. Sometimes it's going to take time till you get your DMLs, but then you want to upload a default data. And even sometimes, in order to do so, if you have more than just one instance, for example, Liquidbase has a mechanism that if I have few instances running on the same database, trying to do modification in the database, what they're going to do is to keep a lock. But what's going to happen if, as part of these updates, one pod will be destroyed? The lock will be just there, and you need to do a lot of manual intervention. So this is not good. Another example you see here is a Prisma. And here it's both more complicated. What they try to do here, it's running the SEMA in an init container. So they decouple it, the migration. But again, every time there is an issue, the crash loops, the way the Kubernetes is running it again and again and again, it will just trigger the same issue. This is not a way to orchestrate a database changes. And of course, if you need to do a rollback, or if you need to debug, it's much harder to debug this init container if it's running or not. This is not the way we would like to handle it. So one of the solutions that we see today is to create job. You can run job as Kubernetes, running in Liquidbase. It's going to be amazing. But again, the main issue here is that, okay, it's decoupled. But now, if I need to do a rollback, I don't really understand what's happened. The schema is just garbage in, garbage out. Maybe Liquidbase know what to do with it, but again, Liquidbase will not be able to understand what's happened and to reflect it on a change. So we'll do it very, very quickly. The problem here is that we want to be clear on schema changes. We want to simplify the way that we declare it. We do not like to make changes. We want to declare the current state. And to do so, this is a project called Atlas. It's a cloud-native operator. And just to give you one example, or maybe two examples, what you see here, we have Atlas schema. It's a declarative CRD. I'm defining my SQL, and what's happening behind the scene, the Atlas operator, upon understanding that there is a change because the reconciliation loop was running and understands there is a change, it will consult the Atlas operator. Atlas operator will have one hand into the database, one hand into the change that I want to do, and he will decide if you want to apply it or not. And why it's so, and I will finish it here, why it's so amazing, because it's declarative, you don't need to change and manage database schema alerts. Alters. Because right now, if you just want to add age attribute as int and not null, what's happened behind the scene, that it will detect that it already exists, and it will just perform an alter table and add it. So I think this is a great time to speak about another thing, which is monitoring.
Yeah, so that's the final part of our talk, fast lane monitoring. And here's the thing about monitoring. You've added more instances because you noticed that there is a bit lagging in when the query runs, right? Here's the question, why? Not why the query still is running so slow. The question is, why did you add more instances? How did you know what was the issue? If the answer is not monitoring, you better listen to this part. Because here's the thing. You have, I'm assuming that either you're in the midst of migrating to Kubernetes or you're already invested fully into Kubernetes. So you probably have some kind of monitoring for the other resources that you have. But what about databases? Why don't you have monitoring? Why don't you invest time in having monitoring over the databases, over the queries that you have running? And I think I know the answer to that. And maybe it's because the way I see it, it's that monitoring is a little bit like writing tests for your code, which can be tedious, but then if you don't have it in the moment that you need it, you're going to regret it. And so here's a solution for you. Okay, it's not our favorite thing to do, but if we can find a golden path, something that does not require a lot of effort in order to have some baseline of monitoring, this is something we can live with, us as DevOps and also the developers. And here's the suggested golden path. So if we take a look at the CRD, and it's the exact same CRD that we've already used in our previous examples, we will see that a specific Postgres cluster can be monitored using the Prometheus operator resource. And we do that by setting the enable pod monitor to true. And that's it. What are you going to get? By enabling the enable pod monitor, we're exposing Prometheus endpoint with a lot of useful metrics already baked in. And this dashboard that you see on the right side or on the left side, depends on which side you're on, this dashboard is generated by using the metrics from Prometheus in Grafana. And this dashboard was actually, and this whole example is just taking out of the Cloud Native PG Grafana dashboard. It's in their repo, and it's that easy to use. So here's an example that's a great example for a golden path. That's not a lot to do, and it's already there. But here's what's beautiful, at least in my opinion, about being a DevOps. You should think about enabling both of the users, the developers that want that golden path, but also the users that want some more complex way to do things, or they want something that they can have different variety of queries to go with their metrics. So here's a way to do that. So for those who need more specialized data, Cloud Native PG supports a custom approach. And this approach supports power users by allowing them to extend and modify their monitoring setups by this part. And that's great. Providing a config map with tailored SQL queries, this gives them the flexibility to customize their monitoring to meet their specific requirements. Now let's take a look at this very quick example. How are we on time? Like 2 seconds. So that's an example of how we can expose active connections metric. And with that, I will give you the key takeaways very, very swiftly, because we already did the entire talk, and I'm sure you remember everything already, So key takeaways: consider cloud-native databases. It's time. You have everything else running on Kubernetes. Come on, just do it. That's a key takeaway. Another one, shift left and treat schema as infra. That's a good thing. We already talked about it. And then remember that no one-size-fits-all solution. That's always true, not just for databases on Kubernetes. And last, bridging the data and DevOps gap, that's crucial, because involving those DevOps engineers in the database deployment and planning, that's essential. And with that, we will both say thank you.
Hello, my name is Juan. Just a quick question though. You mentioned Grafana for logging, and what you actually show right now, can this actually work also for Datadog too, or just Grafana? For your logging, basically how you had for the logging, right? You saw the metrics and everything, right? And I saw you using Grafana. Can this actually be implemented also for Datadog too?
So we specifically don't use that, but maybe.
Okay, thank you.
We specifically have a separate, but every company is different, so.
Okay.
Cool.
Thank you so much.
Thanks for the talk, and then we can talk afterwards. But my question is about, I'm very happy to see you guys going forward with this project and doing the approach of the microservice, which is very important. I'm really happy that you went down that path. And even the Atlas, the declarative approach for schema changes is great. I've never tried it. I want to get your feedback about the accuracy of changes, because at the end of the day, Postgres is a transactional DDL supporting database. And basically, how you find using Atlas in everyday database change management for your applications? Basically.
So, this is an amazing question, because it's still very, very fresh. What I mean, most of the time, when you speak about taking your schema changes into the left, most of the time you spoke about just running it as part of the CI/CD, maybe run the linter on the SQL and make sure it's okay. But what Atlas tried to do here is another equation. If we're managing our database in Kubernetes, or let's say not in Kubernetes, we manage our database with an IAC. Why not handling the schema changes as an IAC? And one of the flavor of Atlas, and this is not the first flavor, their flavor, most of it, is running in the GitOps observation when you have a PR with the schema changes and it's running on the flow. But here, I wanted to take another angle, because this is a traditional, this is what they're trying to push. This is experimental plus, let's say, but I'll be frank, it's still experimental, that is shifting you even one step and saying, why should I treat differently? And I love cloud-native PG. So if I spin up the cloud-native PG and I can fully do it in a declarative way, why does creating a table, a user's table, should be different when the same mechanism of reconciliation, understanding all this lifecycle can be used for me? And I think another very important key point is that when And I was a developer for many years. When I had a task to manage database and manage schema, I created the schema, but on the next time, I didn't thought about what will be reflected as a new one in declarative way. I just thought about the changes, about the alters. And this is not a good way to handle it. This is why I think this project is something that we can consider. Thank you so much.
Thank you all. Thanks. We got to get the next folks up, so
Wow.
thank you.